Have you ever wondered about the mysteries of the smallest planet in our solar system, Mercury? Let's dive into the fascinating world of this celestial body that exists in close proximity to the Sun, a factor that greatly shapes its unique characteristics. Being the nearest planet to the Sun is no small feat. Mercury is constantly bathed in intense solar radiation, which dramatically influences its surface temperatures. Imagine a world where the sunlit side can reach scorching highs of around 800 degrees Fahrenheit, or 430 degrees Celsius. Now, contrast that with the dark side, which can plunge to chilling lows of negative 290 degrees Fahrenheit, or negative 180 degrees Celsius. That's a temperature swing that's hard to comprehend. This extreme thermal dichotomy is a direct result of Mercury's thin atmosphere. You see, unlike Earth's robust atmosphere, which acts like a protective blanket, regulating temperatures and shielding us from the sun's potent rays, Mercury's atmosphere is so thin it's barely there. It simply can't retain heat effectively, and that leaves the planet exposed to the sun's intense radiation. Mercury's proximity to the sun not only affects its temperatures but also shapes its rugged terrain. Imagine a landscape that's heavily cratered, much like our moon, bearing the marks of countless collisions with space debris. Without a substantial atmosphere to act as a shield, Mercury's surface is a testament to the brutal reality of space. It's a cosmic shooting gallery out there. So what we see in Mercury is a planet of extremes, a world that exists in an environment of intense heat and radiation, with a thin atmosphere that can't quite protect it from these harsh conditions. This proximity to the sun sets the stage for Mercury's extreme and unique characteristics. A fascinating subject that continues to captivate scientists and space enthusiasts alike. Mercury's surface is a rugged terrain, heavily cratered and resembling Earth's moon. This smallest planet in our solar system offers a landscape that's a testament to the power of celestial impact. Its surface is marked by an abundance of craters, the result of collisions with space debris over billions of years. These impact craters are a stark reminder of the planet's vulnerability, left exposed without a substantial atmosphere to shield it from incoming meteoroids. Beyond the craters, Mercury's surface also boasts expansive plains, akin to lunar Maria. These plains, believed to have formed from volcanic activity, paint a picture of the planet's dynamic geological past. Adding to the mix, we have scarps, or cliff-like ridges, some stretching hundreds of miles. These scarps are thought to be the result of the planet's interior cooling and contracting, causing the surface to buckle and thrust upwards. But what of Mercury's atmosphere, or rather its lack thereof? Mercury is wrapped in a thin exosphere, a tenuous layer composed of trace elements such as hydrogen, helium, oxygen, sodium, and potassium. It's so thin, it's practically a vacuum, and it's this vacuum-like state that contributes to Mercury's extreme temperature swings. Without an effective way to distribute heat, the planet experiences fiery days and freezing nights. Even with this harsh exterior, Mercury holds its own mysteries. For instance, despite being bathed in the sun's intense heat, certain regions near the poles remain in permanent shadow. These perpetually shaded craters offer respite from the scorching solar radiation, and it's here that scientists have identified areas where water ice may exist. This discovery challenges our preconceived notions about Mercury's harsh conditions and adds a layer of complexity to its intriguing surface. Despite its harsh exterior, Mercury's surface and thin atmosphere hold intriguing secrets. As we continue to probe this resilient world, each discovery peels back a layer, revealing more about the smallest member of our solar system family and indeed about the cosmos itself. Mercury's orbit is highly eccentric, taking approximately 88 Earth days to complete one revolution around the Sun. Now, that's a pretty swift journey even for a planet. But what's more intriguing about Mercury's orbital dynamics is its peculiar spin-orbit resonance. You see, as Mercury dances around the Sun, it completes 3 full rotations on its axis for every 2 orbits it makes. In simpler terms, if you were standing on Mercury, you'd experience only 1 day every 2 Mercurian years. Now isn't that something? This unique spin-orbit resonance didn't just happen by chance, it's a result of the gravitational interactions between Mercury and the Sun. Mercury's close proximity to the Sun means it's subject to strong gravitational forces, which have gradually brought its rotational period into a stable resonance with its orbital period. So what does this mean for the little planet? Well, it leads to a distinct rotation pattern that's unlike any other planet in our solar system. This pattern results in a long, drawn-out day-night cycle on Mercury. So long, in fact, that by the time the sun rises, sets, and rises again on Mercury, 2 Mercurian years have passed. Mercury's unique rotational pattern also affects the planet's surface temperatures. Because of the slow rotation, the sunlit side has ample time to heat up to scorching temperatures, while the dark side cools to icy lows. It's a stark contrast that epitomizes the planet's extreme existence. It's these peculiarities, these eccentricities, that make Mercury so fascinating. Its orbital dynamics reveal a planet that's constantly in motion, dancing a unique waltz with the sun. The gravitational forces at play have shaped Mercury's spin, its day-night cycle, and its surface temperatures, contributing to the planet's distinctive character. Mercury's orbital dynamics add another layer of mystery to this fascinating planet. It's a world of extremes, of stark contrasts and peculiar patterns, all governed by its complex dance with the sun. And as we delve deeper into Mercury's mysteries, we gain a greater understanding of the intricate dynamics that shape the celestial bodies in our cosmic neighborhood. The Messenger spacecraft provided a wealth of information about Mercury during its mission, which concluded in 2015. This remarkable probe, the Mercury surface, space environment, geochemistry, and ranging spacecraft, orbited the planet Mercury for 4 years, capturing data and images that have significantly expanded our knowledge of this enigmatic world. One of Messenger's key discoveries was the chemical composition of Mercury's surface. The spacecraft's X-ray and gamma-ray spectrometers detected a wide range of elements, including magnesium, silicon, sulfur, and potassium. Surprisingly, Mercury's surface was found to be rich in volatile elements such as sulfur and potassium, which are easily lost to space. This finding contradicted earlier theories that Mercury would be deficient in volatile substances due to its proximity to the sun. The Messenger spacecraft also discovered that Mercury has a global magnetic field, much like Earth's. This revelation was unexpected since Mercury's small size and slow rotation were thought to preclude the existence of a dynamo effect, which typically generates a planet's magnetic field. Yet, there it was. This magnetic field, albeit weaker than Earth's, has implications for Mercury's interior structure and thermal history. Perhaps one of the most exciting discoveries made by Messenger was the evidence of water ice in permanently shadowed regions near Mercury's poles. Despite the planet's extreme temperatures, these areas are never exposed to direct sunlight, allowing them to remain cold enough to trap water. The existence of water ice on Mercury was a thrilling find, as it suggested that even in the harshest of conditions, water, the elixir of life, can persist. These discoveries challenged our understanding of Mercury and opened new avenues of exploration. They've shown us that Mercury is not just a barren, scorched world closest to our sun, but a planet of surprising complexity and diversity. And as we continue to explore the cosmos, who knows what other surprises await us on Mercury and other celestial bodies in our solar system? The Bepi-Colombo mission, launched by the European Space Agency and the Japan Aerospace Exploration Agency, holds promise for further insights into Mercury's mysteries. This joint venture, which arrived at Mercury in 2025, is set to delve deeper into the planet's unique characteristics and unravel the secrets that lie within its rugged terrain. One of the primary objectives of the Bepi-Colombo mission is to study Mercury's magnetic field. While the Messenger spacecraft confirmed the existence of a global magnetic field on Mercury, there are still many unanswered questions. Bepi-Colombo aims to provide a more comprehensive understanding of this magnetic field, its origin, and how it interacts with solar winds. The mission also intends to examine the composition of Mercury's surface. The extensive cratering, plains, and scarps tell a tale of the planet's geological history, shaped by eons of meteoroid impacts. By studying the surface composition, scientists hope to gain more insights into the planet's formation and evolution, its geological activity, and the processes that have shaped its current state. Furthermore, Bepi-Colombo is tasked with investigating Mercury's exosphere. This thin envelope of trace elements, though hardly an atmosphere, plays a crucial role in the planet's thermal dynamics. Understanding the exosphere's composition and its interaction with the planet's surface and magnetic field could shed light on the extreme temperature variations on Mercury. While the mission has its objectives, the potential for unexpected discoveries is immense. For instance, the existence of water ice in Mercury's permanently shadowed craters was a surprising find. Who knows what other surprises this small, resilient planet holds in store? In the face of its extreme conditions, Mercury remains a captivating enigma in our solar system. with ongoing and future missions promising to unravel more of its secrets. Through the eyes of missions like Bepi Colombo, we continue to deepen our understanding of Mercury, opening new vistas in our exploration of the cosmos.